For the curve y is equal to x squared minus 4x plus 3, find the equations of the tangent and the normal at the point 1, 0. Find the coordinates where the normal intersects with the curve again. So we've got y is equal to x squared minus 4x plus 3. If we want to differentiate this, we have to remember that if y is equal to x to the n, then you bring the power down in front and reduce the power by 1. So it becomes nx to the n minus 1. So dy by dx will become 2x minus 4. When you differentiate, you bring down the 1, get minus 4, and this becomes x to the 0, which is 1. When you differentiate a constant, you get 0. At x is equal to 1, dy by dx will be 2 times 1 minus 4, which will be 2 minus 4, which is minus 2. The equation of the tangent at 1, 0, and mt is equal to minus 2, where the gradient of the tangent is minus 2, that's given by dy by dx here. We can find by using y minus y1 is equal to mt, x minus x1. Now it's a good idea to label these points up. This will be x1, y1, and this is mt. Substituting in the values, you get y minus 0 is equal to minus 2, brackets, x minus 1. So that's going to give me y is equal to minus 2x plus 2. We need to find the gradient of the normal. So the gradient of the normal, n, is equal to minus 1 over mt. That's going to be minus 1 over minus 2, which is 1/2. A little check here is to do a half times minus 2 and check that you get minus 1, which is the condition for perpendicular lines. So we want the equation of the normal at 1, 0, mn is 1/2. So we're going to have y minus y1 is equal to mn x minus x1. Again, labelling up x1, y1, and mn, substituting in the values, y minus 0 is equal to 1/2 brackets x minus 1. So it gives me y is equal to 1/2 x minus 1/2. Okay, we are asked now to find the coordinates where the normal intersects the curve again. So we want to find where this will intersect with this curve again. To do that, where the normal and the curve meet, we have 1/2 x minus 1/2 is equal to x squared minus 4x plus 3, and we now solve this equation. What makes this equation difficult is the dividing by 2 here, so we multiply the whole thing by 2 to get x minus 1, 2x squared minus 8x plus 6. To solve this as a quadratic, to solve it, we must put it equal to 0. So we're going to have that 0 is equal to 2x squared, bring the x over, get minus 9x, minus 1, which is plus 7. And now we need to solve this quadratic. So it does solve by factorization. One way to do this is to do 2 times 7. 2 times 7 is 14. And the sum will be the middle number, which is minus 9. So we want two numbers. When we multiply the two numbers together, we get 14. And when we add the same two numbers, we get minus 9. These are called the factors, and if we've got minus 7 and minus 2, we can check that. Minus 7 times minus 2 equals 14, and minus 7 plus 2 is equal to minus 9. So if it's all okay, then we write this quadratic again, splitting up the middle term into minus 7x minus 2x. It doesn't matter which way round you write these two. So 0 is equal to 2x squared minus 7x minus 2x plus 7. And now we factorise by grouping. So grouping these two together, you're going to have x coming out as a common factor, and you're left with 2x minus 7. And then there is no common factor here, but if we put in a minus sign here and put it into brackets, this plus now must become a minus. Think about it. Minus times a minus will get back to a plus. Now it's a good idea to write a little 1 in front of here now. And now we have that's equal to 0. Now we have a common factor of 2x minus 7, which can come out. So we're going to have 0 is equal to 2x minus 7, and we're left with x minus 1 that we wrote in. From that we can say that either 2x minus 7 is equal to 0, which gives x is equal to 3.5, or x minus 1 is equal to 0, which is x is equal to 1. We already know this value because that was given to us in the question. We knew that was because we had to actually find the normal at that point. So we're just going to concentrate on this one. We need to find the y coordinate. So when x is equal to 3.5, or 7 over 2, we're going to have a y is in the normal y is equal to half x minus a half. If we put 7 over 2, it's easier to deal with that. So we get a half times 7 over 2 minus a half, which is 7 over 4, and then a half is the same as 2 over 4. 7 minus 2 gives me 5 over 4. So the tangent and the curve meet again at 7 over 2, 5 over 4, or if you want to write it as decimals, 3.5 and 1.25. Although we're not required to draw a graph of the thing, if I would draw a graph, it would look in autograph. Here is my original function. This is the point where I'm asked to find the tangent, which is the blue line. And this is the point where we have the normal. If you are going to use autograph, you must make sure that you have 1-to-1 ratio on the axis. Otherwise it won't look like a normal. So we can see this normal meets again at this point, 3.5, 1.25. The graph was not required for this question though.